In this video, we're going to continue to look at beta oxidation, and we're going to look at the problem that occurs when you have an odd number chain fatty acid. Because if you remember, normal beta oxidation will chop off carbons in groups of 2. Well, if you have a fatty acid that's an odd number, eventually you're going to be left with 3 carbons and have propanol coenzyme A. We need to get rid of this propanol coenzyme A. And so the way we do that is we're going to convert it to succinyl coenzyme A. And then that can enter the citric acid cycle. And there's 3 steps to this. 1, we add carbon dioxide via propanol coenzyme A carboxylase. We get methyl melanol coenzyme A. It's the wrong chirality though, so we need to switch chirality using the enzyme methyl melanol coenzyme A racemase. From there, we need to rearrange the carbon skeleton again, and a mutase will do that, the methyl melanol coenzyme A mutase, and there we get succinyl CoA, the citric acid cycle intermediate we all know and love. Now, what's weird, at least weird to me, is that this succinyl coenzyme A that we make isn't actually directly consumed in the citric acid cycle. We need to convert succinyl CoA to pyruvate, then acetyl CoA, then it can enter the citric acid cycle. So the way we do that is we convert succinyl coenzyme A to malate. We'll transport it to the cytosol. We will decarboxylate malate and make pyruvate via malic enzyme. Then this pyruvate can be oxidized via pyruvate dehydrogenase and enter the citric acid cycle. Now, we've been talking about beta oxidation. I said at the very beginning this happens in the mitochondria. However, some of this can also happen in peroxisomes for mammals. And peroxisomes will handle our long chain or branch fatty acids. What peroxisomes will do is that they will shorten their very long chain fatty acid. So if we have a fatty acid greater than 22, peroxisomes will help take care of that. We do that via 3 enzymes. Acyl coenzyme A oxidase will catalyze the reaction of fatty acyl coenzyme A plus oxygen gets our trans delta 2 enol coenzyme A. So then we have a peroxisomal enol coenzyme A hydratase and 3L hydroxyacyl coenzyme A hydrogenase. This happens in the same protein, so this is basically reactions 2 and 3 of the fatty acid beta oxidation. So nothing that different really. Then you have peroxymal thiolase, which will catalyze this final step of oxidation. However, this enzyme does not work with acyls less than C8 or less, so again, peroxisome is specialized for our very long chain fatty acids. And with that, that's the end of this video. I will see you in the next one.